Okay, for our Pre-Algebra 8.3 lesson, we are learning about quotient of powers property. So we're still working on exponents, but today we're dividing, because if you remember what the word quotient means, it means to divide, the answer when you divide. So let's look at the first problem. We have a fraction, but remember that fractions are just division problems. So we've got a 4 to the 5th power divided by a 4 squared. I want you to think back to when we expanded these, expanded notation, and let's write out off to the side what 4 to the 5th power would look like if you expand it. It would be 4 times 4 times 4 times 4 times 4. And on the bottom we have 4 squared, so that would be 4 times 4. Okay, and then if I covered up all of these 4's on the top on the numerator, and if I covered up one of the 4's on the bottom, we're looking at a problem that's just 4 divided by 4. And I know it's been a while since you guys have done fractions or division problems, but any number divided by itself is just 1. So, I mean, I can do that in the calculator. I can show you that, oh, that was actually 5 divided by 5, which is 1. 4 divided by 4 is 1. 100 divided by 100 is 1. Any number divided by itself is 1. So if I were to take, sorry, I'm still supposed to be covering these up. If I were to take that top 4 and that bottom 4 and divide them, it would just be 1. So there would really be no need to have the 4's there, because they cancel each other out and it would just leave 1. So I'm going to do that. I'm going to cancel those two out. And then what I notice is I also have another one on the top and bottom that I could cancel out, because those would also just be 1. But I can't do it anymore. I'm left with 3 4's and nothing on the bottom. Well, technically a 1, but you would keep it invisible, because anytime you have 1, it just takes whatever number you're talking about. So you don't even need to show it. So it's basically 4 times 4 times 4 is all you have left, which means 4 to the 3rd power. And that is the answer. So you could do this with every problem. You could write on this first problem 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2. But that's a lot of writing. So we look at shortcuts. And the shortcut is when you're dividing exponents, and they have to have the same base. So remember, this is a 4 and a 4 for the base. If they have the same base and you're dividing, you can just subtract their exponents. That's a much easier shortcut way to do this. So here's the rule: a to the m power divided by a to the n power. If both the bases are the same, they're both a's, you can just subtract m minus n. So that would be how it works. Okay, let's try a few of these. 2 to the 6th power divided by 2 to the 4th power would leave 2 to the 2nd power, because again, 6 minus 4 is just 2. That would be also easy to calculate out. 2 to the 2nd power is 4, but I think we're actually just keeping answers with exponents for now. So even though the actual simplified answer is 4, let's keep it with exponents for now. So 2 squared. Negative 7 to the 9th divided by negative 7 to the 3rd. We are going to keep the parentheses, because if they were in parentheses like negatives are, we're going to keep it in parentheses for our answer. And 9 minus 3 is 6. Okay, and then h to the 7th divided by h to the 6th, you're going to subtract 7 minus 6, and you have h to the 1. However, anytime in exponents you have a property, or you have an exponent of 1, it's going to be invisible. So it's going to be a final answer of actually just h. And I know people are like, well, how do you know it's 1? It wouldn't even be there at all if it wasn't at least there once. So anytime you have a 1, just leave it without anything, and we are going to assume it's a hidden invisible 1. All right, go ahead and pause the video and try 1, 2, and 3, 4 on this section of try it, and then press play and see if you got them right. All right, this first one should have been 9 to the 3rd power, which is actually 9 times 9 times 9. But you know what? This one actually says leave it in a power form. So if you put the final answer, that's fine. But this one wants it with exponents. So 9 to the 3rd is what we're looking for. This one would be 4.2 to the 1st power. But again, anytime it's to the 1, we're going to leave that invisible. And then this one should have been negative 8 in parentheses. I hope you all remembered your parentheses, to the 4th power. And then the last one would have been x to the 5th power. Okay, for the next section, we're reviewing everything that we've kind of learned so far in our exponents unit, and we're putting it all together in one problem. So this is going to be a little, I'm going to jog your memory from like 2 lessons ago. So when we learned how to do this 2 lessons ago, I'm ignoring the divided by because that was today's lesson. So if you had a problem that just looked like this, 3 to the 4th power times 3 squared, anytime the bases were the same and you were multiplying, our shortcut was you add exponents. So 3 to the 4th times 3 squared, if I ignore that bottom part, that would be in the numerator 3 to the 6th. And now we've got this 3 to the 3rd on the bottom, but now we're going to drag in our new lesson that we've just learned today. We're dividing, and if you're dividing numbers with the same base, you can subtract their exponents. So final answer here would be 3 to the 3rd. Oh, and this section said evaluate, which usually does not mean give it in a power. It usually means give it as a final answer. 3 times 3 times 3 would be 27. You can also check that on your calculator. Okay, if you're ready to try it, go ahead and pause the video. Some of these are a little tricky though, so I am going to work them out with you if you're not quite ready to do them on your own. But if you are, pause the video now. Okay. What you should have done for number 5 is exactly what we did up here, which is add the ones that you're multiplying. So that would have been 6 to the 10th power. 6 to the 5th is the denominator, and then you could have subtracted. So this would have been 6 to the 5th power. And oh good, they want us to keep it as a power. I was like, that's going to be a really big answer if you put it in your calculator, but leave it as a power, which means leave it with its exponent form. Number 6, we didn't do one like this, but for now, I would leave 2 to the 15th in the numerator and work out the bottom, work out the denominator, which is 2 to the 3rd times 2 to the 5th, which would be 2 to the, you're adding when you're multiplying, you add exponents, so that'd be 8. And then you are subtracting when you divide. So that would leave our final answer as 2 to the 7th. All right, and then the last one, the numerator is m to the 8 plus 6, which is 14. The denominator was m to the 5th, and then you would subtract when you divide, which would leave a final answer of m to the 9th power. All right, let's turn the page and look at a few of these on the back. All right, this looks difficult, but this is actually the same exact thing we've been doing. Let me jog your memory to 6th grade. In 6th grade, when you learned how to do fractions and you multiplied, you can multiply straight across with the numerator and straight across with the denominator to get your answer. And so that's what we're going to do here. So if there was no denominator, it would just be -4 to the 9th times -4 to the 8th. And we know that when you multiply same bases, you can add their exponents. So this would be -4 to the 8 plus 9 is 17, right? Okay. And then on the bottom, you would do the same thing. So since we're multiplying and they have the same base, you can add the exponents. So -4 to the power of 7. And then this is our new lesson. When you have the same bases and you're dividing, you subtract exponents. So the final answer is -4 to the 10th power. And this is how we're going to do all of these. So let's try one with just variables. You'd still do it the same way. Numerator can be multiplied by numerator, denominator multiplied by denominator. So a to the 10th times a to the 7th would be a to the 17th. That's my dog drinking water, if you can hear that, if you're wondering what's going on in the background. Sorry about that. It's Rocky. A to the 6th times a to the 4th would be a to the 10th. Yep, he's a really thirsty boy. And then you're going to divide, which is subtract, so final answer is a to the 7th. Wow. Okay, this is entertaining. All right, go ahead and pause the video and try these last 3 and see if you get the same answers I get. Okay. If you have already done it, you should have gotten -5 to the 13th power divided by -5 to the 7th power, which is a grand total answer of -5 to the 6th power. I hope you remembered your parentheses. Number 9, you should have gotten d to the what's that, 14th? Over d to the 9th. Be careful. Remember that d has a 1. It's invisible. So 1 plus 8 should be 9. And then when you subtract, your final answer is d to the 5th. All right, and then the last one, oh, this one's a little tricky. We haven't done one like this. But again, if you're multiplying and you're multiplying, then you're multiplying all of them. So the whole top row, the whole numerators can be multiplied. So 3 plus 6 plus 4 is p to the power of 13. Bottom row, denominator is 2 and the hidden invisible 1, which means p cubed. And then you can subtract because we're dividing for a grand total answer of p to the 10th. We're not going to worry about the word problem in today's video. We'll come back and catch it another day.